Okay, in this video we're going to talk about rendering characters, creating a font file that contains characters that are outside of the standard ASCII character set. You remember here we were dealing with just from the bang to the tilde here. Now we're going to look at characters outside of that set. And for historical purposes, we're going to look at a thing called Windows Code Page 1252. This was actually one of the first attempts to internationalize an operating system and make it accessible to people who speak languages other than English. So Microsoft came up with this idea of using the negative numbers that can be stored in a byte. So you get this whole bottom half of this thing. These are all the negative byte values if this is a signed character that we're looking at. See, here's the first, in hexadecimal, here's the first digit in hex, and here's the second digit in hex. This is literally the 0th value, and it is the null character, which terminates any standard C string. It's that character right there. And then here's 21 in hex, which is the bang, and here's 7E in hex, which is the tilde. So there's the visible characters that we're familiar with. And then Microsoft decided, okay, we're going to use the negative region. We can put all these other nifty things in here. And this just happens to be code page 1252. There are many other code pages that contain other characters or even weird little graphical marks. Sometimes you've seen those things in totally keyboard-driven menu systems where they have neat little windows and little squiggly things. That's what this stuff's all about, right? Okay, so those things exist too. But the problem with this way of doing things is that you only have so many characters that you can deal with when you're representing a character with a single byte. So in order to use different character sets in the negative region of the byte, you have to load different code pages, and you can only use one code page at a time. Plus the fact if you make a file that uses a particular code page and you send it to somebody overseas and they open it up and they don't have the same code page, it doesn't make any sense. You also have to have a font that understands how to use the code page. So in any event, they decided they had to come up with a better system than this, and that's where UTF-8 and Unicode comes from. Now I'll describe what that is in more detail later. But like I said, for historical purposes, let's extend our ASCII character set that we already have by adding these new characters that we don't have. So we can write in German, for example. Okay? I mean, that would just be one, thing that we could do with this. So, okay, so I'm going to minimize this. I made this, where is it? Let's go back here, add to text, and look at new, and in here you'll find, there it is, UTF-8 chars win32. This is in new.txt. And, okay, here is the entire positive region of a byte. That's standard. That's the standard ASCII. And here's all the characters that Microsoft added when they created that thing called a code page. All right. And there's something I gotta also that I want to point out here, but I'm not going to get into too far. But I do want to point to it. Is there's these things here. Okay. These things here are called diacritics. These diacritic marks, these weird little marks, they're very special in the way that they work. Typically, when you are in a string of text, you can see the cursor, I just dropped it right there. You move the cursor along, and any time you type a key, it populates the space of the cursor and moves forward, So like we can go, 0, 1, 2, 3. It keeps moving forward this way, adding a character. Okay. Well, it is possible to type a normal O, like this, and then type an umlaut character right after that, and you'll end up with a character that looks like an O with an umlaut over it, but it's actually two consecutive characters. And the weird thing about it is when you type a diacritic, it does not advance the cursor. It actually just becomes an element of the current, the last visible character that isn't a diacritic that you typed. Okay? So that's kind of weird. But at the same time, there are whole glyphs that do not require 2 consecutive key entries of like O followed by an umlaut. There are the actual composed letters themselves of this is a single character, O with an umlaut, which is not the same thing as an O followed by an umlaut. Okay, anyway, that's all a little bit of background information, and we'll be getting into all that stuff a little bit later because I did have to write all kinds of neat code to deal with this whole diacritic thing. Okay, so we have this thing. We know that these are the characters because I literally copied these characters out of that code page thing and just pasted them in here. So when we run this file, it generates in the UTF-8 folder a file called win1252, and win1252 is going to be in, of course, the UTF-8, and here it is, and we open it, and this is what we get. So here's all the characters that are in standard ASCII, plus all of these other ones that we didn't have before, all the way up to the trademark symbol. And you might notice these are in different order than they were, and there's a reason for that. And also, because this contains those diacritic things, this report tells you that. It says Win1252 contains diacritic marks that add to the previous character and do not advance the text cursor. So now you know that. And it's weird because sometimes a text editor knows how to handle them and sometimes it doesn't. So anyway, here's the complete set. Now, here's the problem that I just ran into. I normally use Ubuntu, so I didn't realize that this was an issue until someone brought it up on the Photon Lexicon that's been kind of exchanging comments with me about how to use this. And he said when I try to run this and when I try to do stuff in Inkscape, it crashes. And I thought, okay. All right, so normally we would say, all right, let's copy this whole thing. This is our Inkscape copy-paste thing, right? So let's copy it. And then, make sure I got that. Copy that. Okay. Go into here, and we pick our text cursor, and we're at Arial. We're at Arial. Let's see. Normal, 144. I'm just checking everything. So, okay, we're good. And we drop our cursor and paste. Okay, there's the whole thing, which is cool. That's what we want. But again, this just has one single space between each character. So now if we go up to the spacing thing and we say, I want to increase the gaps between the characters or the interval of the characters are placed to 200, it did it. Well, that's interesting. That's normally where it crashes. So for whatever reason, we cannot render all of the characters that we want in a font set in one single line because Inkscape just doesn't want to play along with it. Okay. So what we can do is let's just go ahead and go to here. Remember I said this is live. This is editable text, right? So let's just take out all right, there's everything. Okay, we just removed standard ASCII. Well, see, now it's gone. We took out from the bang to the tilde. The first 94 characters are not here, so all we have is the characters that go beyond the ASCII character set. All right, so we already know how to render this. I'm gonna go in to, we're gonna 5 again, except this time we're gonna go with Arial 1252. Okay, so we got these characters. Now the issue is if we were to just open up the previous Arial character set that we had and then concatenate this character set onto the end of it, we would certainly get all of the characters, but the problem is the characters might not exist in the same dimensional space because the way LaserBoy does things is all relative. It looks at the total height of the string of characters from the very least of the lowest Y value to the highest Y value, determines that height, and then it uses 3 times that length, that height, whatever, to do the thing, and then it scales everything accordingly to fit into this frame nicely. So it just so happens that chances are likely that these characters are not exactly the same size as... Okay, it looks like we have a busted character here, busted glyph. So that means we got to go back to Inkscape and we got to undo. Okay, edit, undo, there. Alright, so now we just kicked out that spacing 200 step that we did, and this, if we're here, see, we can edit this again. Alright, so it's live again. Alright, so now if we go to spacing, remember we did it at 200, so I'm just going to spread them apart a little bit further. I don't know, there's some magic harmonic convergence or something that happens, because remember I said this whole thing is based upon the actual height of the entire string of characters, you know, and then it moves along that way. So somehow or another it's a hit and miss. Apparently I would think it would get all of them, but it didn't, so we're changing it. Now they're further apart. Okay, and we do the path, object to path again, and the file, save as, revision 12 DXF, and replace it. Alright, back to here. In 2, 5, Arial 1252. Alright. And the one that was missing, yeah, we're good. Anyway, they're all the base, it's this base letter with these added things called diacritics. And remember, I mentioned that before, this is one single Unicode character composed of these two elements, but the two elements, of course, exist apart from each other. Bring this down. Shift V. All right, now here's something we're going to do that's kind of interesting. This is how we're going to line the other one up. All right. So, okay, turn that bitmap off. Just because I want to change the color of this thing, select the whole thing, and make it red. All right, so now it's red. Now I'm going to output a bitmap file. And it says, save as a 1000 pixel square bitmap file. Okay, this is 2D lit vectors only, BMP, save of the current frame, 1. And we're going to call this Arial A. Alright. And now that exists. So now we can go I, 6, 8, Arial A, and we don't need to scale it because it is the same size as the background. It's 1000 pixels square. There it is. Alright. Now that is not vector, that is a bitmap. As a matter of fact, you see, it's the background of our current view of this font. Alright. So now we know how big an A is, which means if we, remember we moved this down, right? So we're going to O, 1 for an ILDA file, 3 to go into fonts, and we're going to save the whole font set as Arial 1252. All right. And then we're going to go I import 1 for ILDA, 1 to stay in the fonts directory, and we already know we have, well, yeah, Win10. Yeah, Win10 Arial. Let's replace the current frame set. Okay, and there it is, right? Now this is Win10 Arial that we made before, but if we go to the letter A, we can see it's too big, and so we can actually Shift D shrinks it actually pulls the camera out, right? So we bring this down, so it's about the same size, and we need to pan it over some, so that's the Q key. We move it like this, right? And now if we do a Shift V and apply this scale and pan to this thing, now we can I to import, 1 for Ilda, 1 to stay in the current fonts directory, and we're going to get Arial 1252. We're opening that, and we are going to append it to this. Add it to the end, which is 4. Boom. There, it did it. So now, hit the semicolon key, that goes away. We start at the bang, and we end with the trademark. We have everything in between, and all of the font characters are in the same space. Alright, so next thing we want to do is we want to import a UTF-8 file, 8, and we know that we have this win1252.utf8, so we're going to open that, and now there's your 21. All right. Each one of these in hexadecimal, each digit in hexadecimal represents exactly 4 bits. If you take 4 bits and 4 bits and put them together, you get a byte. Okay? So anything that can be represented in 1 byte, 8 bits, can be written in exactly 2 hexadecimal digits. So anything that's preceded with all these zeros can be represented in 1 single byte. But you'll notice that you get through, and by the way, remember the standard ASCII is up to this 7E, right? So that means that this is still a byte. It's just, it's in the negative region of the byte value. Or if you think of it the other way, it's kind of a strange way to think about it. It is actually a number, if you think of it as an unsigned integer, it's a number greater than 127. Because remember, 127 is 7F. So this is still a byte because it only takes up 2 hexadecimal digits to represent it. But you'll see that there are in fact values here that take up, this is a byte and this is a byte. So it takes 2 bytes to represent this diacritic thing. And this trademark symbol right here, obviously this takes 2 bytes. This is a byte right here, and this is a byte right here. And that's really how the whole UTF-8 Unicode thing works, is that they came up with a way that you can still interpret this as a string of consecutive bytes, but some of the characters that you will find in this string of bytes actually take up more than 1 byte in order to represent the whole character. So this is a byte and this is a byte right there. So that's what this symbol is. It takes 2 bytes to represent that thing. Okay. So in any event, this now exists and it is properly named, and we can save it out 1 1, and we'll just go ahead and call it Arial 1252. Yes. And now it exists. Now we have that.